Probably not my fault. Yeah, the presentation today is about future directions of C# and Visual Basic. When I say future direction, what I mean is we will be talking about things that are in VS 2010 for the first half of the presentation, and we'll be looking at things beyond 2010 for the second half. So that's what I plan on doing. But before we start, you have probably noticed that in the title there is both C# and VB. And how can I speak about the future of both languages at the same time? Aren't they two different languages? By the way, how many, can you raise your hand if you're a C# programmer? All right. VB programmer? All right. So I can speak about the future of both because of a strategy that we are on that is called coevolution. Once upon a time, the way C# and VB would evolve would be that one language would insert one feature, the other language would put a different feature, then the first language copied the feature from the other one, then the first brought one in, and the customer base were all confused because they all wanted something that was in the other language. And moreover, we were starting to see library vendors that will structure their libraries in such a way as to use some particular feature that was specific of one language and not the other. And so we were in that kind of we were maximizing unsatisfaction, if you wish. So we decided that wasn't a good way to go. And so we embarked on this strategy called coevolution for VB and C#. What coevolution means, it means that in the future, you won't see any big feature inserted in one language and not in the other. Okay? So if we add one big feature to one language, we will add the same capabilities to the other one as well. Right? Already in VS 2010, we moved the two languages much closer together, so that now we are in a good spot to co-evolve them as one. Okay, obviously the syntax might be different between a feature in one language and a feature in the other, but whatever language you pick, you won't be wrong. You will have the same capabilities that the other one has. Okay, this is about coevolution. And this is my last slide of the day, but I'm going to speak for an hour on it. No, I'm just joking. I'm not going to do that. So when we see at the programming languages out there, we see all those new programming languages. It's nice to see how many new programming languages are popping up. It's like the whole field of programming languages was frozen with Java and C# for such a long time. It's nice to see now dynamic language and other things coming, functional language coming to steal the spotlight, if you wish. When we look at all of that, we see three big trends. The first one is a trend toward being more declarative, a trend toward telling the system not how to do things, move those variables, move bits left and right, but what you are trying to achieve. A trend toward communicating with your system at a higher level, if you wish. The second trend, which is, in my view, tied to the first, is the move to concurrent programming. With all those multi-cores that are right now in your laptop, I'm sure that if I ping any of you on the laptop that they are using right now, they probably have a multi-core laptop in there. Maybe? 4? Oh, man. So invidious. Anyway, so... Okay. That proves my point, I guess. And in the future, we all will need a way to master all those core. We'll need a way to make all of them work. We cannot write application that just use one core and leave 3 of them idle without doing anything. In my view, declarative is a prerequisite for concurrency. If you write your code in a more declarative way, then the system can take your code and kind of make it run of all those different cores more easily. And the third one is this emergence of dynamic languages. The fact that you just want to write your code, don't worry too much about the types in your code, going from prototyping things to running code in a very fast fashion. So that's another big thing that is coming up, that we see as a trend. And if you are a C# or VB programmer, you can write code in this fashion right now. All of those things are ready in C# and VB. So let me show it to you. Magic. Okay, so I'm going to write an application for the whole rest of my presentation. What I want to write is a CSV reader application, a comma-separated something. It's something that reads. You got to wonder what the V is for. Values. Thank you. I was about to say comma-separated files, like files. But anyhow, so the CSV application that I want to write is an application that goes and reads whatever CSV file you might have. If you're familiar with dynamic languages or framework like R or MATLAB, they all have this nice function that you call load CSV, and then you can start accessing all the data inside the CSV file just by doing dot and writing the name of the column. So I want to write something like that. This particular CSV file is a CSV file that we are using to track. We are in the process of porting the C# compiler in C# and the VB compiler in VB.NET. Now they are both written in C++. I would explain to you why we are doing that later on in my presentation. But this is the CSV file that has the name of the file that we are porting, the directory, and this left total is the number of lines that we still need to port. CSV file all work the same way. They have, the first line is like the title of the column, and then there is all the data. All right, so let's try to write that code. So I need a bunch of imports. I'm going to write both VB and C# code, and I know that you guys can understand them both the same, right? Yeah, all right, that didn't go too badly. All right, I will need this guy later on. And then I will say public module CSV reader. A module is just a nicer version of a static class if you are a C# programmer. And I'm going to use snippets for my presentation so you don't need to see me kind of type code. The first thing I want is a way to represent my CSV file. So I choose to represent it this way with the class CSV content that has something that represents the headers of the file, and it's just an IEnumerable of strings because it's just a bunch of strings, and then an IEnumerable of array of strings, so it's a matrix, in essence, that represents the data in the CSV file. I have a print function here that just prints out the headers and prints out the data. All right, so now that I have that, I can I can write my read CSV function. This function takes a file as a first parameter. Then it takes an index, which is the column number I want to query over, and the value I'm looking for. So this function will return a CSV content that contains all the rows for which the column has that particular value. Is that clear? You guys with me? Yep? Okay. So the code is rather simple. I create a new CSV content. I read all the lines. I get the headers by splitting the first line in the file. I create a new list to store my results. Then I do a for loop that starts from 1, because the line 0 is the headers that I already retrieved, and go to content.length -1, because the for loop in VB is inclusive, so you have to say -1 there. And then I'm getting the values that are on each line. Then I'm testing, is the value at that index is equal to the value that was passed in? And if it is, then I'm adding it to the results, and at the end, I'm assigning to data my results, array list. Okay? I can then go and call my function, which reads the CSV file and prints out the result. And if I run it, I get what I expect. All right, so this is probably the way, kind of the easier way for you to write this code. This is a very imperative way to write this particular code. Let me show you a more declarative way to achieve the same goal. So this is a link query. And let me show you a third way, just to have more fun, to write the same one. So all these 3 snippets of code do exactly the same, do the same operation. The second, this one, and the third one are really identical. In fact, the compiler takes this one and converts it to something like this one. I have a bit of a preference for the highlighted one over the other one. I'm probably the only one in this room that likes the latter code more than the previous one. But given that I'm the one giving the presentation, all right. So let's talk about the difference between these two ways of doing the same thing. Let me talk to you about what this one does first. It says I have a comment, I have a content, I want to skip the first line, I want to select all the values, and just the ones when the index is equal to value, and then select out such values. So the difference, think about the best way I come up to explain the difference between imperative and declarative. Think if you are the next guy that comes and have to maintain the code, okay? Or think if you are yourself after 1 year that you have written this code. Let's say that you go and you see the code on the top, the one highlighted. Well, you would look at this code and say, all right, the guy is new in a new list, then he's doing a for loop, but he's starting from 1. So maybe there is a bug there. For loop start from 0 maybe. Then he goes, he has an if statement. Then if the if is true, then he takes the value and push it in. Listen to what I am doing. I am not describing what I want to happen. I'm describing shifting of bits in memory. You know what I mean? I'm far from the conceptual things that I wanted to convey with this code. I'm in the mechanics of it. Yeah, is that clear what I'm saying? And if you come here and you look at this code, and you come after 1 year, you will say, all right, I just have a content, I'm skipping the first line. Oh yeah, that's probably is the headers. Then I need to split it. I get in just the ones. the text tells you, the flow of the information tells you what's going on. And you are expressing things at the same level that your mind originally thought about them. You know what I mean? And there are other advantages as well. For example, let's say that you want to make this code run in parallel, right? Maybe you are loading a humongous CSV file. Yeah, I have no idea. But let's say that you want to make it run in parallel. Well, if you written your code like this, you can just say as parallel. Done. Now all your code will run, all that query in there will run in parallel. The reason why it's so easy, it's because you have expressed your intention at a higher level. And so the system can go and optimize it in the best possible way. Now, if you know about the task library that we are shipping in Visual Studio 2010, you would know that there is a parallel for loop in there. So you might say, all right, but I can parallelize the one on top. It's easy, so fine. And you can do that, and let's write that code. You will do something like this, parallel for, from 1 to content.length. The parallel for is exclusive, so you don't need a -1 there. You will pass a lambda to this guy. Need to close my parentheses. By the way, this is a new feature in VB, multi-line lambdas, but that's beside the point. So yeah, you can write this code. You can make the code on top parallel with, a bit more effort, but probably not too much. The problem is that code is wrong. That tends to be a problem, yeah. And the reason the code is wrong is that in this line of code, right here, all those different threads that you're spinning are all accessing your results collection. And you haven't locked your result collection for multi-thread accessing. So, it might break. And that's exactly my point. You can indeed write parallel code in an imperative fashion. And you might also make it run. It might run a couple of times. It might run for quite some time. But suddenly, it might not run. And it's very complex to keep straight locks and all those things, that will make that code. Well, in this case, the code is so simple that you can easily fix it. But as your program grows, you are much better off writing your code in a declarative fashion so that, parallelization, it's done for you. You don't need to manage those details. And this is, if you thought that the code on the top was right and there was no bug in there, then, you understand what I mean when I say the parallel code it's tricky if you write it in an imperative way. So we have seen now, well, I should run it maybe. Just to make sure. Yeah, it runs. All right, so we have seen the difference between declarative and imperative, and how, writing declarative code is almost like a prerequisite to write parallel code, at least in my personal view. It makes it much easier. So now let's move on. Let's make this guy a library so that I can call it from my other project. And let's open up a C# project. All right, so now I have a library. I have a kind of a low-level libraries that reads the CSV and, kind of brings me back some representation of a CSV file. If I want to use that library, I could just call it like that. And then then when I try to access, I immediately realize that that's not, that's not the kind of API that I want to expose to my programmers. I mean, it just gives you the headers as an array of strings and then a blob of data. You want to give them something nicer to program with. So let's look at how you might want to structure your API. You might want to do something like that, to just have a get CSV file, do a for each over all the lines of the CSV file, and then access all the data by the name of the column. Okay, so this is, I would argue, this is the simplest API you might want to give to your programmers. And you want this get CSV function to work for whatever CSV file, right? Not just for the particular CSV file that I am using in this example, which is going to introduce some complexities in the code. And indeed, you couldn't get this to work before Visual Studio 2010 with exactly this API. So let's go and write this code. So first, let's write the get CSV function. Get CSV just calls our low-level function, gets back a CSV, does a for each over all the lines in the data, and yields out a new object of class CSV line. Okay, so fine. Let's go and look what CSV line looks like. All right, so CSV line is a simple thing that has data and headers. All right, so you are returning a CSV line, which means that this guy right here is of type CSV line. So how do I now allow people to call dir name, ported, left total line? Well, one way of doing so is to add strongly typed properties to my CSV line. That works. I mean, that works. That gives you the API that you want. But the problem there is that it just works for that particular shape or a CSV file. If your CSV file has a completely different shape, that's not going to work. So that's not the way to go then, because you want your API to be generic. So let me, oh wow, what did I do? Uh-oh. All right. So you might then think, well, I can add an indexer. Right? So you add an indexer here, and the indexer, the way it works, it just picks up the element in the data that is at the index, that was passed in as a string. Actually, let me grab this code as I will need it later on. All right, so now you have an index, so now your CSV line is generic. Right, it can work with whatever CSV file that you might have. The problem is that here, you don't have this nice syntax, right? The way to call an indexer is to pass strings. So all your calling code will look rather ugly. You would have all those strings in there. It wouldn't look like the way it looks in all those nice dynamic language when you just load the CSV file, you do dot, name of the column, and you are off running. You have all these, these square brackets and strings and everything. So again, this is not what you want, right? You really want something more. And until now, there is nothing more that you could have done here, unless going into some crazy, no. So you couldn't get, you had the choice. You had to choose or something that appears to be, strongly typed with dot, or something that is specific for this CSV file. So in Visual Studio 2010, we introduced a new feature called dynamic. What dynamic does, it allows you to get control whenever that dot is pressed. In essence, whenever whenever this executes, instead you can tell the compiler, hey, I want to decide what happens at that point in time. So to get that to work, you need to come here and say dynamic object. So you inherit from dynamic object. You could inherit from an interface. If you could implement an interface if you wanted to, but it's simpler this way. And then you go and you override. In this case, I want to override a try-get-member. And the try-get-member will be called at this point in the code. So wherever this executes, the code goes here. You know what I mean? So in there, to implement this, you have to assign the result parameter there. So you say result equal, then you can pass the code that I have here. And the index now is binder.name. And binder.name, in this case, will be dir name. And in this case, will be ported, left total name, and so on. And then you just return true. Like so, very simple. It's almost as simple as writing an indexer. So that's all you need to do on this side, while here you make this dynamic. And now, well, it always prints the same stuff, but you know, it works. So you have achieved what you wanted. To prove you that it works with whatever CSV file, I have a new CSV file in here that has stock prices for Microsoft. It has date, open, high, low, close, volume, and it also has a signal. And the signal is if I was long or short. Well, I never short Microsoft stock. But anyway, the signal is what someone working for Oracle would decide if too long or make too short or make long or well, whatever. The signal is just a field in that file. All right, so I can now load I can load my Microsoft thing and just get the one that are long, and then simply go here and change this to be date, this to be low, high, and close. Noting that I haven't changed anything in my CSV line or my get CSV, right? All remains the same. I can simply go and run this, and, well, okay. And you see that now it works for stock file. And I can now go and work on whatever CSV file I happen to have, and I can access it with dot. I have achieved kind of what I was looking for. Okay? So this is the first, this is kind of the first part of my presentation. I wanted to show you how writing declarative code is a prerequisite to parallelism, and how dynamic can be used. Actually, that's not I still have one more demo. And how dynamic can be used. In this case, I'm using dynamic as a producer of an API. I'm creating a dynamic API. That's not, even if it's cool, and there are cases where you will use that, the main reason why we introduce dynamic is not from the production side, if you wish, but is on the client side. So there are many things in the world today that are dynamic. For example, if you're writing a Silverlight app and you want to access the object model of the page, that is an object model that changes dynamically. If you are accessing Office, you are writing Office programmability code. In a lot of places in the Office object model, they return you a variant or an object, if you wish. If you have a set of libraries written in Python, for example, and you want to access them from C#, you will need a dynamic feature, something dynamic in the language. And what we have done with dynamic is we made accessing all of those dynamic things look exactly the same from C# and VB. VB already had a concept of dynamic that will work for COM object and such, but now we extended to work with things like IronPython and so on. So to show you what I mean, I have a demo here of using an IronPython object. So the way that I create, what I used to create that diff file, that CSV file was an IronPython function with that particular signature. And the way to call such a function from C# is just you create a Python runtime, you load the file where the Python function resides, and then you just call the function as if it were a normal C# function. Okay? Same thing if you were accessing a JavaScript function inside a Silverlight application. We'll just call it like a C# function. And you can then access the results, like you would normally in C#. And I can also run this, and it will print done on top. So it works. Trust me, he has done it. But the point is not, the running on the thing. The point is that now you have access to all those different dynamic things, in a very nice way. All right, so this completes the first part of my presentation. So what I've been trying to show to you is that if you are a VB or a C# programmer, all those big trends that are out there in the programming languages, they are already in your language. You can already use them. You can write the code in C# or VB in a more functional way, in a more declarative way. You can use dynamic if you want to create, a reader for CSV file that is, as good as a reader that you could write in a dynamic language. So it's all in there. So all that I've been showing you is something that you can use in Visual Studio 2010. You can download the beta 2 and you can write exactly the same code that I have written. Okay? It's all in there. From now on, I'm just going to talk about speculative things, about things that we are thinking about. Don't take what follows as any promise that we are going to ship those things in the next release, or that we are going to ship them in the shape that I'm going to show them to you. Nothing like that is, maybe I show them to you today and you're never going to see them again. That would be on the unfortunate side of the outcome spectrum, but it is possible. So, and if you ask me for the code for those things, I cannot give it to you. So it's really, things now that Visual Studio 2010 is winding down, those are kind of prototypes and things that we are working on. So the first one, the first kind of area we are exploring is the opening up of the compilers. So right now our compilers, the C# compiler and VB compilers, they are black boxes. You push a file on one side, and on the other side comes out IL. And you have no way of getting into that process, of seeing what's going on inside the compilers. And why would you want to know, right? Well, being able to use the same data structures that the compiler uses is incredibly useful. One thing that you could do is you could create a RAPL window so that you go and you write VB code and it executes directly, or C# code. If you have been, how many of you has been at the last PDC and watched Anders Salzberg presentation at the time? Well, yeah, so some of you did. Yeah, so what he showed it to you was a RAPL window for C#, and he was able to build that because he was working on the internal data structure of the compiler. And other scenarios for these are, for example, if you want to parse your code to make changes in it. For example, doing some aspect-oriented kind of stuff when you weave over your code and you change names of function or things like that. Or a third example would be to build refactorings. And let me explore a bit more this ladder example. Let's say that you want to build a refactoring that takes a piece of VB code and inverts the order of parameters of the first two parameters. For example, it pushes x1 here and x2 here. And it also inverts them on the call site, and so on and so forth. If you had to write this refactoring today, well, what would you do? You would start, all right, maybe I need to write a lexer for VB. I need to write a parser. Well, where is the grammar for VB? And writing a parser, takes... we have an entire team of people in Microsoft doing it, so it's probably going to take you some time. Or you might decide, go and grab a parser from the internet. Maybe someone has written a VB parser, and maybe they have, but is it right? Is that the parser that we use? Does it support all the new features? And so, it will be for writing such a simple refactoring, it will be a rather large project for you to do so. And we want to remove that barrier. We want you to go off and write whatever thing you want in a reasonable amount of time. So if we exposed the insides of the compiler, then writing that code will be about this big. 2 pages of code. It would be 1 page if I were using a normal font. So this is just an example of how you might do it. You would inherit from a rewrite visitor, which is a visitor that walks over all the parse tree for your program. You would check if the node that you are in has that particular name. Notice that I'm just checking if the string is the same. If you were writing that for real, you would, multiple functions might have the same name. So you will need to do something slightly more elaborate. And if you find that name, then you will return a node that is exactly the same as the node that you were passed to, but it just swaps the first 2 elements. And that's it on the declaring side. On the calling side, you will do exactly the same. You will just return a new invocation node that just swaps the 2 parameters, and that's it. That's all the code that you would have to write. Compare then these 2 kind of going and grabbing and finding and doing. So that's one big thing that we are doing. And because we are exposing the compilers this way, we are rewriting them in C# and Visual Basic, so that .NET, so that then we can expose them as managed APIs for you to use. And this works. See? And it works twice as well. All right, so this is the first area I want to talk to you about, where we are, where we are investigating, we are investing resources. The second area is around asynchronous programming. So I've been showing to you that because you have lambdas in the language, because you have LINQ, because of all those features that are now in VB and C#, writing parallel code become as easy as, as doing S parallel. Well, not that easy, but, but it becomes much easier. But there is still an area of parallel programming where things are not, where still you don't have enough power in the language to be able to do things in a reasonably easy way. To run this code, I need to change my compiler to a prototype one, which is here. I can click on this make prototype. That's gonna put the SEM3 file on top of this CSV lang DLL, which is where the compiler resides. So if I say make prototype, Sam is the name of the developer, by the way, in case you wonder. You can see that we tried a bunch of time to make it work. And here I lost track of which one was my original one. But apart from that, so you know that it's prototype code at least. So let's take a look at this code. So what I'm doing here is well, let me show you what's coming up. These two things are just infrastructure things. I'm saying that I don't want to cache a web request. I just want to run it, even if it's in the cache. Don't worry about that one. I have a get web page that takes a URL and returns how many characters are on the web page. The way it works, it creates a URL, called getResponse, gets a stream, a reader, reads all the HTML, it prints out the thread where I'm running my code, and then it returns the length of the page. Then I have a main file where I read a whole bunch of URLs. Let me show you what this CSV file looks like. It has a first column when there is the URL, and then a whole bunch of stuff that I don't use, and it has a first line that has all the kind of the column name. Then I skip the first one because it's the headers. I get the URL. I take the first 100 of such URLs, and then I just, for all those URLs, I call get web page, and so I get back all the results, and I sum them. All right? So if I go and I run this, it's gonna, well, the net is rather slow today. It's gonna, you see that everything is running on thread 1, okay? I haven't created any new thread. I'm not using any parallel thing. So you look at this and you think to yourself, well, there is an easy way to make this run faster, right? I don't need to wait for one request to have come back before starting the new one, right? I can start all of them in parallel, and then, when all of them are done, I can print out the sum. So let's stop this guy. So how would I change my code to make all the requests run in parallel? Well, it's the same thing I showed you before. You just come here and you say S parallel. That's it. I mean, very, very simple stuff. You might want to go one step further and say with degree of parallelism to get the system to give you a bit more threads to run. But that's essentially, all that you need to do. And now everything, it's running faster and it's running on multiple threads. All right? So that's what Thank you. So that's simple, right? We don't need to introduce any new language features to achieve that. So let me stop this. Oh, what did I do? Did I close VS? All right, let me bring it up again. Okay, so that looked very simple to do. So you may think you are done, okay? You may think to yourself, all right, I'm done. But you are not really. If this number here, instead of 20, were 2,000, for example, let's say that you want to extensively parallelize your application, where each thread in memory takes about 1 meg of RAM, and it keeps resources, and you will be in the situation when you have 2,000 threads, all in memory at the same time, all keeping resources busy. And the best thing about that is that they won't be doing anything. They will be there waiting for network data to come back to them. They won't be using the CPU at all. They will be stopped. But they will be using all those resources anyway. So then you look at your code and you think, that's not right. There must be a better way. And indeed, conceptually, what you want to do is very simple. What you want to do is, at this point in the code, while you are waiting for the website to reply to you, you want to release the thread. And so that someone else can use it, because your program is not doing anything at that point. And you just want the system to call you back when the data has arrived from the web. And same thing here. If you run a code the way that is written now, you will be there waiting for all the stream of data to have come to you. So at that point, you will want again to release your thread so that other people can use it. All right, so you would think making things parallel was easy. How hard would it be to make it release the thread at that point? Well, harder than you think. So let me comment out this code. Okay, so it goes, the changes that I have to make in my code go from here to here. So that's the code that you have to write to make it release the thread, to make that thing to run asynchronously. And notice what I'm doing. I need an event here so that I can wait for all the threads to be done. I need to create delegates that I'm passing at the end of this get web page async, so that they are called back when I'm done. Inside my get web page async, I call begin get response, and I have to pass another nice delegates in there. Inside that delegate, I call begin read, and I have to pass a delegate to begin read that goes here, and so on and so forth. And look at, this is called inversion of control. Your code was very nice and linear before, and now you have to take pieces of your code, make them delegate, pass it so that the system can call them back. And then if that delegates does another asynchronous call, you need yet another delegates, and you link all the chain in. And you need to manage all the error conditions of things that might go wrong inside that. And it's you write this code once, and then you forget why you did it. And there is and the code runs, by the way. So it runs, and it runs asynchronously, so it works nicely. It's just a royal pain to write. So, and there is no language feature that you can use now to make this code run, to make this code simpler. So let me bring back my simple view of the world here. So when things were simpler, when we just had our synchronous version of this code, what you really want is to write code that respects what's in your mind, so that that when you go back, you understand what's going on. So we want at this point to release the thread. And we said that we wanted at this point to release the thread. So what if we introduce the keyword here that tells the system, stop my method here and notify me when you're done. And now this will return an async of long. And those are the only modifications that you need to make to your code to make it run asynchronously. Just you have to tell the system in which points of your code you want to release the thread, essentially. That is what you had in your mind. That's what you wanted to do. It's just that you couldn't. But if we implement this feature, then you can. And here, on the calling side, you just need to come here and say, wait for all. And it does run. So that's kind of the second area we're looking at. We look at the asynchronous code that you have to write today, and we decided that we needed to do something about it. And I've said at the start, don't take it as a promise that we are shipping this in the next release. It looks very simple when I but there are dragons in there. But it's good to know that you guys like it. So, all right. Let me go back to my code here, to my slide. So, in summary, the first half of my presentation was things that you can do in VS 2010. All those three big trends, you already have them right now in C# and VB. You can write that code. Things that we are working on, opening up the compilers, making asynchronous easier, and a third thing that I don't have a demo for is make it easier to create immutable classes and things in C# and VB. We have tried to make that happen for quite some time. We never came up with a design that we are happy with. Maybe finally we will in the future. And we need your feedback. I mean, download beta 2, play with it, and whenever we come up with new features as such, continue kind of telling us if we are on the right track or not. This is a very good PDC if you are a language guy, if you like programming languages. Immediately after this section, Mads is going to go, well, after lunch, Mads is going to go and talk about the details of dynamic, how dynamic works under the cover. At the same time, Dino has a presentation of how to enable your application to be scriptable from dynamic languages so that your customer can go and script your app. Lucian is going to talk about the new feature in Visual Basic on the 18th. And my buddy Luke has a great presentation on writing parallel and asynchronous programming in F#. If you guys haven't looked at F#, go to that presentation. It will be a lot of fun. And before that presentation, there is one in the same room by the Axum guys, which is another very interesting programming language from research. And then we have the two fast-paced IDE presentation on the 19th. Go to whichever of those you are more familiar with. And this giant font tells you to please go and fill out the evaluation forms. They told me that they are going to give money to charity, depending on how many you fill. So please do. And that's it for my talk. Thank you very much. And I'm going to take questions now. We have, I left 4 minutes for questions. Oh, there are microphones, I think. Yep.
Yeah. Do you hear me? Yeah. I have one question. You said that you're rewriting the compiler. Do you internally use a kind of compiler that you will provide with us? I mean, last PDC we saw things like mGrammar and things like that. So will you make it easier for us to even write our own languages with our own grammar?
Yeah, so there is the M project. You know, that project is still going on, and we have plenty of presentation here that explain how to use that. The way we are rewriting the compiler right now, we have strong backward compatibility constraints. So we need to throw exactly the same error messages where we are throwing them right now. We have all sorts of corner cases that we need to make sure that we get right. So rewriting them from scratch will be unfeasible. So what we are doing instead is we are porting them so that we are sure that we get the same exact semantics, and then we will be refactoring them to expose APIs to go and manipulate them. So that's the path we are following for those two.
Okay. A second question concerning Link.
Yeah.
Link is a really great thing, and all the dynamic stuff is great. Will there be a kind of Link for dynamic, or even a Link in languages like IronPython?
So Link for dynamic languages, I don't know. I'm not the right person to answer that one. Go to whatever dynamic session we have in here and ask there, and they will give you a better answer than I can speculate on my own. Yeah.
2 quick questions.
Yes.
As far as the async for C# goes, is the intent to just sort of bring that up to the level that F# has right now with the
well, actually, we are implementing the current design that might never ship, is that we are implementing a generic concept of resumable methods. And those resumable methods could be used to implement async, or they could be used to implement other things. And for example, iterators in Visual Basic. With a single design of feature, we might be able to implement both. So it's not async specific.
Okay, and then the other thing is there's kind of been talk about extending expression trees to have statement trees. Is that still?
Yeah, yes, we are working on that. Yeah.
Okay, thanks.
No problem.
I haven't heard anything about extension members. We have extension methods now, but are you still considering extension properties or other members that compile to methods?
Yeah, that's a good question. I will certainly take your feedback and bring it back. I have to say that we have been so focused on the current features that we haven't kind of take a look at the whole list of feature requests and consider them. But thank you for.
Yeah, it seems like a partially good, implemented feature that would kind of complete the whole thing.
Okay. Thank you.
Hi. Is there any way to use IntelliSense with dynamic bindings, or are you planning any?
I would love to, but there isn't now.
Okay.
We haven't. It's a difficult problem to solve. To give IntelliSense for dynamic things, some claim impossible, others claim not. But we haven't tackled that problem yet.
All right. Thanks.
First of all, I would also really like the extension properties. That would be very nice syntax.
That's good. Here is the man that is listening to all the feature requests and with a banana in his hand.
But my question...
He raises banana, which is a good sign when he does.
Okay. But my question was in regards to rewriting in C#. Do you have any idea how this will impact performance of the compiler? Because that right now is one of my major concerns if you compare it to like Delphi and other rapid.
Interesting. To be honest with you, it rarely happened to us to have people complaining about the performance. Which are you using, the C# or VB compiler?
C#. We have a pretty big project.
Yeah,
I
we
think it's
should,
like 15,000 files.
Yeah, we
and
should hook up afterwards.
really large.
We are always looking for a project. To answer your question, I'm sorry, is we won't ship a slow C# compiler. We will have a clear performance matrix that will be tracking, and so you shouldn't be worried. But if you are worried today, that means that we will need to do even better that we are doing, and that I cannot assure you. So we'll need to,
Okay, thanks.
Thank you.
So with the async thing seemingly coming right out of F#, right? Except that it's baked into the compiler instead of being defined in terms of the async block. It seems like other things from F# would be really great to have in C# too, like match and discriminated unions would be really awesome.
There is a whole set of functional features that you can conceivably decide to add to C#, right? And that's the beauty of having so many programming languages on our platform, that we can go and see, and steal things from one another, right? Whenever adding feature to the language, especially a mainstream language like VB or C#, has to be considered very carefully. The language is big, it's getting even bigger. We don't want to make it, humongous. And so what we do is we carefully select the things that change the language the least, and we think they give the most back for the investment. And so what you're proposing is those are good features. We will need to evaluate them in, compared to all the other things that we have on our list. And it seems that for you, they would be on top.
Oh,
for,
yeah,
for,
especially discriminated unions, yeah.
Yeah, for other people, they might not. So,
Thank you.
But those are good suggestions, yeah.
Can you say a little more about the immutability? So how concrete are their plans there? And
So, yes, immutability, we have tried, that I remember, I've seen like 4 or 5 different proposals of how to get them into C#. All of them were nice enough, but we haven't found the silver, something that we are really confident. It touches everything, right? It touches the way that the reference work, the way parameters are passed into methods, and so we are really careful to do the right thing there. And we haven't found the right thing yet.
will this rather be a C# language feature or a runtime feature?
Well, we don't
in
know.
the CLR?
Yeah, it can. Yeah, we don't know yet.
Okay.
We don't know yet. We tend to think of it as a compiler feature, but it might require runtime help to get it completely right, especially if you go between assemblies and So, yeah.
So now that you're synchronizing the feature sets between VB and C#, what's the impact to the agility of rolling out new features now that you have basically 2 teams you have to mesh up? In the past, the C# team had a great idea. They could focus on that and then release it out. Now there's going to have to be some sort of synchronization time, right?
Well, it's more the way that we think about it. It's more like in fact, that's what we did in the team. We unified the 2 teams. So now we have a compiler team that works on both the C# and VB compiler. Well, they still have 2 leads, one for each compiler, but they all report up to the same person. And we have unified the 2 IDEs. And so when we do the feature list ranking or such, we do this across both languages, and then we go and implement them. So I haven't seen, to this point, a slowing down of innovation because of that. And now in this release, we have brought the 2 languages to be so close together that I don't foresee a big slowing down because of that reason.
Do you see different feature sets from the different camps of developers? C# developers want this functionality and VB want
No,
this?
right now our
really
assumptions is that the feature is that the customer base is similar enough that we need to
deliver
build
with
the
a
same
common feature
feature
set.
in both languages.
Okay, Great.
So that's our assumption.
Great, thank you. One more vote for the generic parameters.
For the okay.
The properties, thank you.
Thank you. I think I have, oh, if there is no other speaker, we can continue. If there is not the next speaker. Oh, it's you. Oh, sorry. Oh, okay. Oh, go ahead.
I just wanted to ask a quick question about the number of different ways of doing asynchronous in C#. It seems to be growing by the week with, there's RX and new one you've just shown, begin async, events, delegates. Is there plans on sort of perhaps unifying that or, or at least pushing a preferred way?
So, no, we hope that, by having an async feature in the language, that will be the way to write async code. And we hope that it will be much simpler than all those ways that you just mentioned.
And will some of those sort of old ways be sort of phased out to keep the language small, or now stuff has to stay once it's really in?
Well, so this feature that I showed, we don't know when it's going to ship,
Yeah.
or we also don't know how it's going to ship.
Yeah.
But it will be a language feature,
Yeah.
like all the others.
Because one of the things I was going to ask about actually was, you partially answered, was how do you sort of evaluate keeping the language small and stop it becoming C++?
Yeah, that's one case where writing asynchronous code is becoming so pervasive,
Yeah.
given the multi-core scenario that we are moving forward, is so pervasive, the code is so terrible, and the change in the language is not huge. So it has a whole set of good characteristics that make us think that it will be worthwhile to add it. Other features don't have the same set of positive attributes.
Because I guess you can hack it. I don't know if you've seen the CCR way of doing it, where everything becomes an enumerable, I guess. So it's just sort of standardizing that. So.
Yeah.
Thanks.
Thanks.
Hi. I just wanted to know, are there any plans to add features in .NET or C# or VB.NET to do synchronous resource deallocation and memory deallocation? Right now, everything is done using the garbage collector, and it's asynchronous.
We already have using feature that kind of gives you that, right?
So is there, yeah, we do have using feature, but we support an API where people have to remember to use the using feature. I was just wondering if we can, if there can be any language semantic that would allow an object to be released or disposed as soon as it goes out of scope.
I think you can force garbage collection to happen at whatever point in time, but then you would garbage collect all the objects, not just the one.
Is there a reason why the dispose cannot be called as soon as it goes out of scope? In a language, for instance.
But that's what using does. Using, you wrap your object with using.
Yeah. So why do we need using? Why can't
you can call dispose directly on the object.
Yeah, so why can't the framework call dispose on an object directly as soon as it goes out of scope?
Oh, I see. In general.
In general, yeah. Because that would be a pretty useful feature. In that case...
you don't know the answer? Why would that wouldn't work? At this point, it will also be a breaking change, right? So
I think that it would be a really useful thing, especially our application depends very heavily on unmanaged resources, and we have a .NET wrapper on that. Yeah. And for unmanaged resources, asynchronous deallocation is not an option. So it would be great if you could...
but you cannot use using to wrap that.
We do use using now, but a number of our developers introduce bugs because they just forget to use using. I see. So it would be great if you could have a language feature that does dispose. Now we have 2 or 3 different kinds of finalizers. We have dispose and then we have a finalizer. I understand that finalizer can be for pure .NET deallocation, but for unmanaged deallocation, we do need some language feature that allows us to implement internally.
It's not really a language feature.
Yeah, it's a framework feature.
Yeah, you will need something that maybe you implement an interface different from the one that we already have, and if you implement the interface, then when you get out of scope.
For instance, an object inherits from from a class, let us say that has synchronous reallocation,
And then all right, thanks for the feedback.
Yeah, I just have one more question.
Sure.
Do we have any plans to add more AOP, aspect-oriented programming features in C# and VB.NET?
Not right now.
Okay.
We are all busy in opening up the compiler, and that would allow those features to be written.
Right.
But we have plenty on our plate just doing that at this point.
Okay, thank you.
All right, thank you.